welcome you all to today's lesson. And in today's lesson, we are going to talk about the transformers under physics. So we are going to understand what a transformer is. So I'm going to explain this using exam standard. So even as you are preparing for your exams, you are in the examination room, this topic will really help you. Transformers under physics. I'm going to give all the formulas that are needed, all the formulas that are necessary. So if you are new to this YouTube channel, make sure you subscribe, hit the like button and comment. So let us start. I wrote down this definition of a transformer. So if someone asks you a question saying what is a transformer? A transformer is a device used to vary the voltage of an AC supply. So each time we are talking about a transformer, we are talking about a device that is used to vary the voltage of an AC supply. Some people will tell you that a transformer is a device that increases. So some people will tell you that a transformer is a device that increases or reduces. So it is going to increase or it is going to reduce. So increases or reduces voltage. That is a what? That is a transformer. So each time we are talking about a transformer, we are talking about a device that will increase or reduce voltage. That's why I said that a transformer is a device used to vary the voltage of an AC supply. AC supply, you know that this is an alternating current supply. So a transformer will increase or reduce the voltage. So now, before we go any further, one thing you need to know and understand is that each country has got its specific voltage that they get to use. So they have got its specific voltage of AC supply for the house that they get to use. For example, in Zambia, so you discover that in Zambia, the voltage that we use, the voltage, so in Zambia we've got AC supply of, we've got 240 volts. So this is the voltage that we get to use in Zambia. Some of the appliances that we get to use have got this voltage. But for instance, let's talk of Japan. You discover that in Japan, their voltage of AC supply is 100 volts, like this. So now, meaning that if Japanese electric appliances is used in Zambia, a transformer is needed to change the voltage of AC supply from 240 volts to what? To 100 volts. This is what we are actually talking about. So have you seen? So when we want to use the Japanese electric appliances, we need to come up with a transformer that will change the 240 volts to 100 volts so that it can fit. This is what you need to understand. So if it is connected to a Zambian power supply direct, it may break because the voltage of supply is too high for the Japanese electric appliance. This is what you need to know and understand. So here we are going to study transformers. We need to know what a transformer is. We need to get all the information about a transformer. So what you need to know, the other thing that you need to put into consideration here, the other thing that you need to know is what a transformer consists of. So each time we're talking about a transformer, so a transformer, this is a transformer consists, so it consists, so a transformer consists of, there's what we call the primary coil. There's what we call the primary coil. This is what you need to know and understand. Apart from the primary coil, there is what we call a secondary coil. So all these, you need to understand them. And we've got what we call a soft, iron core. This is what you also need to understand. So this is a transformer. A transformer consists of primary coil, secondary, and a soft iron core. This is what a transformer consists of. So we are going to draw a transformer here. We see how a transformer looks like. So a transformer like this, I'm going to put down a simple diagram of a transformer here so that we understand. So this is a what? This is a transformer. This is a transformer. So as got like this, these are going in that way. So I'm going to do this like this. So here there is one thing here like this. This is how a transformer is. This is called an electric. This is called an electrical appliance. This is called an electrical appliance. This is called an electric appliance, or we can call that as a load. So like this. Then so here, this part here, which is here, this is called the secondary coil. You also need to understand that that is called the secondary. So I'm also labeling, this is called the secondary coil. You need to understand that part. So here we also have, so this thing here, which is here, this part here, this is what we are calling soft iron core. So this part, this is what you are calling soft iron core. That part, this is the part I'm calling soft iron core. This part which is here, here we also have these coils. There are coils here like this. This is called the primary coil. That is called the primary coil. So you also need to understand all these things. That is called the primary coil. Then the primary coil is connected here. This primary coil is now connected to AC supply. This is connected to AC supply. It's connected to AC supply. This is how a transformer is. So this is how a transformer looks like. This is a transformer. So I've labeled this transformer so that we are able to see, we are able to understand each and every term that I've used here. So a transformer is connected to a what? A transformer has got the primary coil and the secondary coil. This part also, a transformer consists of a soft iron core. That is the soft iron core. This part that is here. So then here, this is connected to the AC supply. So if you are told in your exams that how does a transformer works, or a question comes, describe how a transformer works. This is how you are going to describe how a transformer works. You are given this transformer. So the first point that you need to raise, the first point that you need to put is that the primary coil, so the primary coil is connected to AC supply. So the primary coil is connected. So I'm going to do this. Primary coil, so primary coil. So the primary coil is connected to AC supply. So this is connected to AC supply. You say primary coil is connected. So primary coil is connected to AC supply. This is connected to AC supply. It is connected to what? To AC supply. So you are writing down the operation of a transformer, how a transformer gets to operate. So you know that, okay, the primary coil, this is the primary coil, is connected to the AC supply. And the secondary coil is connected to the electric appliance. This is the first point you are going to raise. So you can write down this point. Due to space, I won't be able to write all the points, but I'll be explaining so that we get to understand everything that I'm saying. So we are describing how a transformer operates. So I've said that the primary coil is connected to AC supply, and the secondary coil, this is the secondary coil, is connected to the what? Electric appliance there. So when the alternating current which comes here from this alternating current from the primary coil. So when the alternating current is supplied to the primary coil, it produces magnetic fields and changes the direction of magnetic field frequency. This is what happens. So you know that when the alternating current, this is an alternating current. Let me do this so that we are able to see. I will do this. So when the alternating current is supplied to the primary coil, it produces magnetic field. So magnetic fields are going to be produced. And these magnetic fields which are produced changes the direction of magnetic field frequency. Have you seen the way I've said this point? This is what you need to know and understand. So once this changes the direction of magnetic field, an induced electromotive force of the same frequency is produced in the secondary coil. Here in the secondary coil. So this is how a transformer gets to operate. So you just need to put down 3 points which I've illustrated here. The first point is where you explain this part. You talk of how the primary coil is connected to AC supply. The secondary coil is connected to electric appliance. The second point is where you say that when an alternating current is applied to the primary coil, it produces magnetic fields and changes the direction of the magnetic field frequency. That is the second point. The third point is that an induced electromotive force, which is EMF, electromotive force of the same frequency, is produced in the what? In the secondary coil. This is what you need to know and understand. So this is all you need to know on the transformer. How a transformer works, how a transformer operates. So now, the voltage of the primary coil, the voltage of this primary coil. So whenever you're talking about the voltage of the primary coil and the voltage of the secondary coil, on the primary coil, we need to have the voltage, we need to know the voltage that is here, we need to know the number of turns that are here. Even here, the same thing applies, even this side. We need to know the number of turns there, we need to know the voltage that is in the secondary coil, we need to have all that data, we need to know that data. So what you need to understand is that the voltage of the secondary coil is decided by the voltage of the primary coil. So the voltage that will be here is decided by the voltage that we are going to find this side on the primary coil. And the number of turns in the primary coil and the number of turns in the secondary coil. This is what you need to know. So the voltage that is found here is determined by the voltage that is here on the what? Primary coil. This is what you need to know and understand. The same applies with the number of turns in the what? Primary coil and the number of turns in the secondary coil. So there is a specific formula now that we get to use whenever we are talking about how these are related. So what you need to know and understand is this formula that we get to use. We say voltage in the secondary coil over what? The voltage in the primary, which is equal to number of turns in secondary over number of turns in primary. So this is the formula that we use. This is the general formula that we use. So when you are given the number of turns and voltage then you are taught to find either voltage which is in the primary or voltage in the primary or the number of turns. This is the formula that we get to use. This is the formula that you need to know. So let's make sure that we know the formula, we understand this formula very well. This formula will be very helpful. So even as we get to revise through certain past papers from different exams, we are going to see how we are going to apply this formula. So each time you're talking about voltage and number of turns, the relationship that exists between these two is being summarized by this formula. This is the formula that we are given here. Where you know that here, this is what? This is the voltage in the secondary coil. And this is the voltage in the primary coil. This is the number of turns in the what? Secondary. This is the number of turns in the primary coil. This is what this formula is talking about. So these are some of the things that we need to know and understand. So I want to make this topic very brief so that we know and understand what we are really talking about. We understand what these things are really talking about. We know and understand. This is very helpful. This will help you even as you get to revise through certain papers. So away from this now, we've got types of transformers. We've got types of transformers. We've got types of transformers. We need to understand types of transformers. So we've got types of transformers. So types of transformers. We need to know this. What are some of the types of transformers do we know? The first one, there's what we call a step-up transformer. There's what we call a step-up transformer. Step-up transformer. So what is a step-up transformer? So here, whenever we are talking about voltage, so we talk of voltage. So a step-up transformer, the voltage in the secondary coil is higher than the voltage in the primary coil. This is a step-up transformer. So voltage in secondary, is higher than voltage in primary. This is one point you need to know and understand in terms of voltage. So each time you're talking about a step-up transformer, the voltage in secondary is higher than voltage in primary. The other point that you need to know is the number of turns. So I'll put N here to symbolize the number of turns. So number of turns in secondary, I'll say this. So number of turns, okay, maybe someone cannot understand. I'll say number of turns. So the number of turns in secondary, the number of turns in secondary, so say in secondary are more than in primary. These are two things that you need to understand. So we are talking about voltage and the number of turns. So voltage in primary is in secondary is higher than voltage in primary. Then the number of turns in secondary are more than in what? In primary. So an example that we can set up is this one. This is an example that we can step up. So I'm going to put a simple transformer here so that we understand. Like this. like this. This is, you know that here this is the secondary coil. You know that that is the secondary coil. This is the primary coil. You know that that is the primary coil. We understand that part. Then in terms of voltage, you discover that here if we've got 100 volts, here we're going to have what? 240 volts, like this. So this is an example of a step-up transformer. The voltage is lower in the primary coil, but in the secondary it is higher. In terms of number of turns, as you can see, here we've got a lot of turns. Here there is only a few turns, like this. So this is just an example of a step-up transformer. The same is with the step-down transformer, which is the second one. So the second one is the step-down transformer. So we've got a step-down transformer. A step-down transformer. Opposite with this other one, so just opposite. Step-down transformer. So a step-down transformer, the voltage is high. So I'm going to say high in what? In primary. In primary. Then in terms of turns, number of turns are more. Are more in what? In primary. So number of turns are more in primary. This is what we need to know and understand. The number of turns are more in primary, and voltage is more in what? In primary. So we can also put an example of this transformer, an example of this type of a transformer, like this. We've got this transformer. So here we've got a lot of turns, like this. Here we only have a few, like this. Have you seen? So voltage here we are going to have 240 volts. Then here we've got 100 volts. Then as you can see, even the number of turns are few. This is the primary. You know that this is the primary coil. This is the primary coil. We know that that is the primary coil. This is the what? Secondary. This is the secondary coil. This is the secondary coil. We need to know these two parts. So this is how you get to know and understand what the two types of transformers are. So this is what we need to get. This is what we need to understand. So under transformers, this is a simple topic that you need to know. You just need to understand these two parts, then you are done. So we've talked about a step-down transformer, a step-up transformer, and you are able to give the differences between these two types of transformers. Let us move to the other part. We move to the other part. So, if a transformer has the efficiency of 100%, it is called the ideal transformer. So, if a transformer has 100% efficiency, so if the transformer has 100% efficiency, it is called a what? An ideal transformer. This is what you need to know and understand. It is called an ideal transformer, which means that power in the what? Power in the primary is equal to power in the secondary is equal to power in the primary, like this. So whenever we are talking about this is what you need to know and understand. Power in the primary coil, this is secondary. Power in the secondary coil is equal to power in the what? Primary coil. So here P, this P is symbolizing power. This is secondary coil. This is primary coil. Then this P is equal to what? This P is equal to power. Then this one is primary coil. Which means that you know the formula for power. We know that power is equal to what? Voltage times current. So we are going to say secondary there and secondary, which is equal to power in the what? Primary. So primary, we say, okay, this is the same voltage. Voltage, so I'm going to put P, then current, P there. So this is now the formula that we get to use whenever we want to find the voltage when we are given current, or we want to find the current when we are given the voltage. This is the formula that we get to use. This is the formula that we get to apply. So let's make sure we know this formula. Let's make sure we understand this formula clearly. So before we close, let me give you a question under this. Let us revise through one question and we end this lesson. This is very simple. This is all that you need to know under a transformer. So let me give you a question. Let us revise through one question. Let us look at this question. In my next video, I'll try to give questions now. We are going to revise through questions. So let us look at this simple example. But in my next video, I'm going to do questions. I'm going to revise with you questions from different past papers and we see how we can answer them. So let us look at this question, which is saying a transformer changes voltage of AC supply from 110 to 220. So from 110 volts to 220 volts. The first question we are told to find, it is saying primary coil has 400 turns. Find the number of turns in the secondary. So in the what? Secondary. Want to find the number of turns in the secondary. So how can we find the number of turns in the secondary? How can we find the number of turns in the secondary? So first thing you need to know that you know that this transformer is changing from to what? From 110 to what? From 110 to 220. So you ask yourself, what type of a transformer is this? What type of a transformer is this? So you know that it is changing from this one to that one. So you've got low voltage in the what? You've got low voltage in the primary, then higher voltage in the secondary. Meaning this is a step-up transformer. This is a what? A step-up transformer. So you are taught to calculate the number of turns. You use the formula where you say voltage in the secondary over voltage in primary is equal to number of turns in secondary over number of turns in primary. This is the formula we are going to use. Where we've got the voltage in the secondary, it was changed from 110 to 220. So 220 is the voltage in the secondary. Over voltage in the primary is 110, which is equal to, then you calculate the number of turns in secondary is the one you want to find. So I'm going to leave it like that. Then I say over number of turns in primary 400, like that. So what I need to do here is I multiply these two. So I need to multiply here. So what I'm going to do is that I'm going to say, when I cross multiply here, I'm going to have 110 NS is equal to 220 times 400. Then I divide both sides by 110. I divide both sides by 110. This cancelled. So I've got the number of turns in secondary are equal to. So the number of turns in secondary are going to be equal to what? So I check here. If I multiply here, if I say this by that, what am I going to get? So I know that 110 there, it is 1. 110 into 220, it is 2. 2 times 400, it is 800 tons. So it is 800 what? Tons. That is your answer. So we are yet to go more on this. I will revise with you certain questions that we get to find in an exam. We are going to revise this together. So make sure you've subscribed, make sure you like this video, and if you want tuitions in science, you can contact me on this line. This is my line. You can contact me on this line. You can WhatsApp me or call me. This is my line. You can call me or WhatsApp me. This is my line. I do offer tuitions in mathematics, chemistry, and physics online. So you can contact me on this line. I can help you. If you are a GC candidate, internal candidate, grade 10 to 12, and the GC is, we are doing tuitions, you can WhatsApp me on this line. Thank you so much.